Okay, we have Aleksej.
Hi, everyone.
Hey.
Thanks for joining us.
And we have Max. So, you have one person who's already a fan.
Yeah.
And so, what you going to talk about?
We're going to talk about engineering excellence.
Well, I know I have a scenario, but what is engineering excellence?
Well, we'll try to explain that during our presentation. So it's not an easy topic to explain in 2 sentences.
It doesn't sound like an easy topic. I don't even think I will understand half of it, because engineering is something, well, it's not an NFT, okay?
Yeah.
I'm that smart, not more. Okay, so I leave you here. You are a very nice person. I really like you. I already ashamed you in front of a camera in the expo. Shame on you who didn't see. But he also, he made me talk about my period in front of a camera. Yeah, the same reaction. Okay, I so regret. Anyway, so Aleksej and Maxim from Flow Health, the stage is yours, and I will try to make less jokes today.
Okay, thanks a lot for your nice intro. Yeah, the microphone's back. Okay, I think we're ready to start. So again, hello and welcome to our session where we are going to try to talk a bit more about engineering excellence and how do we do it at Flow Health. And to start with, let us introduce ourselves. My name is Aleksej Klebanskij, and I work at Flow at a team that is called FID, and we're a part of user-centric stream. And today with me is Max.
Yeah, hello everyone. I'm Max, and I'm Director of Engineering at Flow Health. I'm responsible for engineering strategy and culture in my teams, and today, together with Aleksej, we're going to share some insights, how we work, and I really hope that you could find something interesting for you.
Okay, so function of engineering in the organization. So at Flow, we believe that the function of engineering in our organization is to help the product organization to efficiently deliver value to their customers, right? And this is where we come in as engineers, so we enable them to do that. And we believe that efficient engineering is made out of 2 components. First is delivery, second, continuous improvement. And we try to do exactly that at Flow. We try to deliver and continuously improve. But the question here is that how can you tell whether you're improving or not, right? To do that, we try to measure everything. So in this presentation, we'll try to show you some techniques and engineering practices that help us and hopefully yourself to stay efficient. And you can, by the end of the presentation, hopefully, when you leave this audience, you can come back to your company and hopefully implement some of those, right? So a couple of words about Flow. How many of you know what we do? Okay, quite a few. So yeah, we're an app, and we're #1 app in health and fitness category in iOS by installs. And at the moment, we have more than 200 million installs. That's a crazy number to comprehend. 12% of women in the US use Flow, and we have over 33 million active users every month. And in Lithuania alone, how many of you are from Lithuania? Okay, quite a few as well. So in Lithuania alone, we have over 2,070 downloads. And then our monthly active users is around 80K, so 80,000. So that's quite a lot on the Lithuanian scale, right? And we're much more than a period app. So we think that we're supporting people from their first menstruation to the menopause. And hence we have different modes in our app. So we have a tracking mode, we have trying to conceive mode, pregnancy mode, postpartum mode, and menopause mode. And like I said, cycle tracking is only a fraction of what we do. So we have multiple products inside one app, and I really encourage you to try all of them. That is a content library. This is exactly where my team works. So my team we work on the content library. That's the second tab of the app that is called Insights. We also have courses on health and well-being. We have Health Assistant. We have Secret Chats, which is an anonymous and safe place to share the information with other users of Flow. And currently our team is around 360 people worldwide, and 46% of those work in product and engineering. So quite a big team.
And a few words about our organizational structure. We built our teams around complex and comprehensive domains. Also, our team have to be capable to implement end-to-end functionality and do discovery in these domains. That is why our teams are stable and cross-functional. Also, our teams form streams, which represent bigger area of our product. And in streams, we have something like common prioritization, and it helps us not to be siloed and work together around complex switches. And we have platform teams. They behave in the same way like a product, but for internal customers. It's not a secret that we are a mobile application, and I could say that we are mobile-first application, but under the hood, we are a truly backend-driven company. You could see our typical structure only with one iOS, one Android engineer, but with 3-4 backend engineers. And it's helped us a lot to experiment, just because it's much easier to do on server side. Small overview of our main technologies. I think we forget to add something here, but it's still huge. And the last, but maybe the most important slide, because today we are going to cover a lot of things related with engineering excellence, related to delivery, but honestly, it doesn't matter without product impact, and this is our main driver. In our company, we use OKR framework. I believe a lot of you should know about such approach of work, and every team has own OKR and contribute directly to company OKRs. We don't have a lot of levels, and it helps us to be more transparent. And I think it's all for this introduction, and we could start.
Yeah, nice. Let's go. So that's for the introduction, and back to engineering excellence, main topic of the presentation. So why do we need engineering excellence in the first place, right? We really believe that at our scale, and I showed you the numbers earlier, that the mistakes are quite costly. And we do develop large-scale data-intensive system, and privacy and security are one of our main priorities. With that said, people do rely on Flow on their daily basis, and this is where the efficient engineering really helps. And last but definitely not least, or rather one of the most important things, is that we want to be able to quickly test our hypothesis, aka run the experiments. And this is what we enable our product teams to do. And I would like to start talking about cycle time. How many of you here heard about this? Heard this term? Cycle time? Anyone? Okay, some. Okay, so maybe you didn't hear about this because you're skeptical towards metrics that describe the efficiency of the engineering teams, right? Maybe you think your engineering team is already efficient enough. Or maybe you think that your product company use case is unique and you have really exceptional case that is hard to measure. So I'll try to prove you wrong, and let's see how it goes. Cycle time is one of our main metrics to determine whether an engineering team is efficient, and it's metric over gut feel, right? So we're not saying the team is efficient because we feel so, probably a bad idea to measure such a complex thing as software engineering with your stomach, right? And at the end of the day, probably your use case is not that unique. And I could argue that your tasks can be split into smaller ones. And another reason why we use cycle time, and you should start using it, is that it will tell you a lot about your process and how efficient those are, right? And once you learn that, you can start improving those. So basically, everything in your process, from code review to pipelines to QA cycles and tasks that are sitting there just waiting to be delivered. So this is a quote from the famous book. I'll let you read it, but the grasp of the quote is that managers tend to ignore cycle time because they feel that they're already efficient enough. And we like to measure stuff, so we do measure cycle time. Another point why you should start using cycle time is that cycle time encourages less work in progress tasks. And that means that people have to less switch the context, right? And this is again a chart from the famous book called Systems Thinking. I'm sure all of you know it. And by looking at the chart, you could see that by adding another project, so here's a person working on a single project, and here's a person working on 2 projects, 3 projects, 4, etc. And by, sorry, wrong slide, yeah. Yeah, so by adding just one project, you lose 20% of the time just due to the context switching. And if you think that, that's completely crazy, right? So again, measuring cycle time and trying to make it short gets more things done. Okay, so maybe you're still not convinced, right? So another argument is that Dora Report really recommends doing that. How many of you are familiar with Dora Report? Okay, some. So yeah, they also say that lead time or time to market is one of the top performance metrics for capturing effectiveness of the development, right? And the interesting thing here is that it works both ways, meaning that speed enables stability and stability enables speed. So let's talk about how do we do that at Flaw. So at Flaw, we treat cycle time as a metric, and it's for us, it's a time that it takes to bring any kind of backlog item from in progress to done. Simple as that, right? It's a simple but powerful thing because it lets you look at all the processes that are happening in the background. So we measure it per team. So every team tries to measure and improve it. And our North Star is 1 day. So that means that we'd like to be able to deliver any task within 1 day. And that's, of course, on average. We look at those control charts in Jira, and during every retro, we ask us questions. So basically, what made us slow with longer tasks, and what made us efficient or successful with the faster ones, and what action items can we derive from that, right? Also, one of the points is that it's a really good thing that encourages transparency inside the company. So everyone can look at anyone's cycle time, meaning that, well, that could be your peer or your manager, whoever is a person of interest. So for example, Max, as a director of engineering, could maybe think that my team is doing okay just by looking at the cycle time, instead of talking to me and asking how is my team doing. And then again, even though we try to measure it and we try to improve it, but there will be exceptions, and there are some tasks that are long-lasting by design, and that's totally okay. So, this is where we started. So we started doing and measuring cycle time. So that's you could see here that our average was 5 days. it means that on average, it took us 5 days to deliver any task inside the sprint. And this is where we are now. So now you can see that our average is 2 days and 9 hours. It's still far away from our North Star, which is 1 day, but I believe we're on a good way there. So meaning that our team is predictable. So it means that any task we can deliver within that time frame, and we're pretty convinced that we can do that because we have a rich number of data points that we analyzed.
Yeah, I would like to confirm that Aleksej and his team did a great job, and it's also true to say that a lot of our teams try to work in such ways. And in the second part of our presentation today, I'm going to cover some technical aspects which could help us. As a lot of good companies, we try to adopt best practices, and we have a rule that every team is working on technical improvements every sprint. We don't invest a lot in big refactorings during this quarter, just because it's contradicted the main idea of refactoring. It's about incremental changes. And you could see how it looks at scale. The main idea of this quarter to keep our team moving at the same speed or even get faster. And of course, if we are going to achieve this, we need to think about how to form this quarter strategically. It's much easier to do when we have something like common-wide task, for example, some kind of migrations from Kinesis to Kafka. It was our previous experience. Why it's easier? Of course, it's a really hard task, but from point of prioritization, it's absolutely clear that we need to do this work, we need to achieve this goal. But what to do in other cases? And it's also important that we as managers don't want to be bottlenecks for our teams. And even opposite, we would like to give our teams freedom to make their own decision, but at the same time, we need to achieve our quality bar. Trying to find an answer here, we were inspired by ideas from evolutionary architecture, and I would like to check how many of you know about that. Raise your hand, please. I don't see a lot of hands, but honestly, it's really trendy topic, the same like metrics, which Aleksej mentioned in his part. In a nutshell, it's about incremental changes in your architecture relying on fitness functions. And these fitness functions is kind of navigator to decide state of your system. It sounds pretty straightforward, yeah, and easy. And if you ask me about the most challenging part, I will definitely answer that this is fitness function definition. The main problem here that we don't have a lot of good examples, especially if we're talking about mobile applications. And examples which exist, it's more about like health check. For example, it's about unit test coverage, it's about some static code analysis checks. Even if you use something complex like libraries which could help you to describe all needed interaction between different layers, it's all about health checks. But we try to find system-wide function. And despite all these challenges, our developers also were inspired here. And in our company, with the approach, which called architecture decision records, we try to record all our main architecture decisions. And this one is exactly about this, challenge. And a funny fact here that our developers proposed some set of functions, but they were rejected by our developers just because it's more about health check, not about how to navigate our system to needed state. But the good news here, working around this document, we think a lot about our approach, how we work with this technical quarter, and decided to try one new approach. I believe that a lot of companies who deal with mobile application use statistics like you can see on that slide. But honestly, only few of them try to use some practices from site reliability engineering here, like error budget and SLO. We decided to try, and first of all, we defined our SLO. SLO, or service level objective, it's internal agreement between your team and between your product needs. And it's really important. This is internal and depends on your maturity. For example, in case of this crash-free sessions, we know that our developers are mature enough to achieve these numbers. And at the same time, we know that there is a direct correlation between amount of these errors and rating in the app stores. Also, we decided on approach, and it's called error budget. In case if we meet our SLO, it means that our team could use our technical quota in any way they want. In case we are below some indicators, it means that we exceeded our error budget. And in this case, we have to understand which team owns this part of code, and this team stop to innovate and stop to experiment. Their main goal to meet our SLO again. And it's working pretty well. I highly recommend to try, but honestly, it still doesn't affect our code base, and it means it doesn't influence our cycle time. That is why we started another experiment, and it's called like churn versus complexity graph. I post the link to original article, and I highly recommend to try if you deal with monolith application like big mobile, like for example, big mobile application or server applications. First of all, just because it's really easy to implement. What you need to retrieve some statistics from your code static analysis tools. For example, we use it from SonarQube. Also, you need statistic about churn of your code. When I'm talking about churn, I mean how often your classes change during some period of time. For example, in our case, it's about 6 months. And just visualize it. That is it. In our company, we use Looker, but honestly, it doesn't matter. And every point on this graph represents, that's me too. What's good? No, I mean, I would like. Oh yeah, every point on this graph represents class which evaluated by 2 axes. One of them is complexity, and another one churn. And if you want to use statistics, it's better to split up this graph into 4 quadrants. And when we are talking about bottom quadrants, honestly, it's not really interesting. Just because you see complexity is low, it means that no issues here. But another situation, if you're talking about top quadrants, and in case of the left quadrants, we see we have a lot of complex classes, but churn is not really high. What does it mean? Maybe it's our legacy model which not under active development right now. We don't have a lot of use cases. And it means that it's not really beneficial to focus on this area. And we have absolutely opposite situation in the top right quadrant, because we see that our class is here complex and with high level of churn. And the main idea that you have to focus on the code, not just complex, but which change very often. We validated this approach with our developers, and it works really well. Also, our engineers came up with the idea to add unit test coverage here, and we introduced something like integral scroll for our tech date function. In case if complex class fully covered by test, we could reduce the overall score. It's questionable just because if you have complex class and this class fully covered by test, it means that maybe it will be really hard to maintain this test because you need a lot of mocks, stubs, etc. But still, it's worked pretty well. Also, we considered that our tech quota is finally error budget. But in SRE, when we're talking about error budget, we're talking about uptime. And development team monitor this value, for example, monthly, and make decision to continue innovate or they need to fix something. In our case, our error budget based on this function. In case every quarter we analyze these statistics and choose the most complex classes. Also, we define teams which own this code, and this is a primary responsibility during this tech quarter to decrease this complexity. And in overall, it all works really well. And it's crucial that we build a system when our teams could innovate, but they have real constraint. One of these constraints is SLO, and another constraint like error budget, it's our tech debt function. And all these changes related with this tech debt function could increase our cycle time. Proszę?
Yeah, what I would like to add is that for me, as an engineering manager, those are also really important things. So the systematic approach that Max just explained, because I want to know that the team is working on the most important things, and I'd like to measure that. So just to give you a quick summary for those who just joined, key points that we'd like you to take away from this presentation. First, consider cycle time as one of the main process efficiency indicators. Try to measure it, try to improve it. And yeah. Second one, if you have tech quota, try to treat it as an error budget and find your own fitness functions. Meaning, try a systematic approach to reducing your tech debt rather than, again, trusting your gut feel. And third is establish a routine for continuous improvement around cycle time and those fitness functions. I believe that's it. We really thank you for your participation, and we're hiring in Vilnius. We opened an office just a couple of months ago, and we're looking for many bright people, so please feel free to scan this QR code, and you'll find the link. It will link you to our career page. And, now I think we're ready to take questions. Okay, I see. Hi. Mm-hmm. Okay, I'll try to repeat the question for those who are listening. So the question was, how are we determining the complexity of the classes? Is that correct? Okay.
Yeah, thank you for this question. Honestly, it's pretty simple. We use SonarQube. Maybe you're familiar with this tool. And this tool could measure your complexity. They use same like cognitive complexity. When we're talking about complexity, we measure all amount of cycles, all amount of if condition, etc. And together with it to add some special rules which SonarQube as main maintainer of this approach could provide you. That is why it's not a secret, and it's you could try it because SonarQube sometimes available in a free version, and it's just this statistic. This is why I encourage to try. It's not something complex. Also, maybe you could use something more easier, or when you develop something, you could use something like linters, and all these linters also could evaluate your code in point of complexity, and you could use these statistics too.
Thank you. More questions? Yes. Okay, so the question was whether when we're paying off our tech debt, whether we're just refactoring or covering with unit tests.
Maybe I will also would like to discuss about this term of tech debt because it's really wide and it depends on different situation. For example, if you're talking about tech debt, which are real compromise between product owner and the team because we need to achieve something and it's not possible to do in short times with needed level of quality. It's like tech debt which we pay in our product capacity time just because it's visible tech debt and it was our decision to do this way, but we have to pay and product owner know that the team have to pay them by this capacity. It's like mortgage, yeah. It's if you loan money, you have to return them. In case of tech debt, which just because, for example, we thought that we do something in the right way, but we discover that maybe it was mistake or maybe it's not really good way. In this case, of course, we understand that we have to pay it, and for that we use this quota. If point of test, honestly, we have something like definition of done, and all our new code have to be covered by this test, and it's not like a separate movement. It have to be done together. You refactor your class, use test. Test could help you if they are written right. It helps you to iterate with all these changes, and that is why, yeah, it's really hard to answer this question in a simple word, but you have to do it in balance. It's not possible, for example, to write something after that to write test. It's better to do together, and when talking about tech debt, it's more about which were we saw that we did something right, but it was a mistake. For these cases, we use this quota.
Okay, more questions. Yes. Yes. Yeah, exactly. Mm-hmm. It's a good question, but it's difficult to answer yes or no. So I'll try to expand a little bit. So as we already showed, shorter cycle time encourages small tickets, right? And smaller tasks means that it can be done by multiple people. It can be basically done in parallel. So to answer your question, whether that is a trade-off, well, I'd say it depends on different cases, right? But at the end of the day, it's a decision made by product. It should be a decision made by product organization. And we from engineering will basically offer product organization those kind of trade-offs. And then we will try to split the tasks to as minimum amount of story points as possible. So it's not either or, I would say. It's
Alex, could you add here? Maybe I understand this question in another way. Question was about, if we are willing to decrease the cycle time, is it important to us not to deal with end-to-end functionality, but just with some task? Yeah, in this case, we just measure this subtask, and of course, we could achieve these results really quickly. But it's not like our goal. Our goal is more about to think about right decomposition. For example, in case of big functionality, even if you're talking about some kind of migration, we could do something with a stop. After that, we could remove this stop and continue to iterate and to add additional improvements. If you're talking about something like mobile application functionality, in that case, we try to think in terms of minimal valuable product, and we define many use cases and try to implement them as soon as possible. And only after that to add additional functionality. That is why we definitely not want to be a feature factory when we just to decompose all tasks on layer it, for example, to prepare a database. Yeah, it's honestly it's not a real good example because it's sealed. Yeah, and this task doesn't matter. Also, it says that it's not possible to use our laptops, but we use some channel in Slack when we post all our updates. And for example, if our team work on something, it's we would like that even small updates have to be on production. That is why during the day we see a lot of these updates. If you do small refactorings, it's better to integrate and push to prod. That is why, yeah, the question is not goal to decompose to stupid task. It should be real use cases, but we have to split it vertically.
Okay, thanks. More questions, please. Yeah. Okay, so the question was whether we use any specific techniques to split the bigger tasks into the smaller ones. So one technique would be just to have a refinement meeting, right? And just try to ask questions like, can this be done in parallel, for example? Can this be a separate deliverable? Would it make sense to deliver this task alone? And what are the benefits? What are the trade-offs? So I can't remember any specific techniques that we use. Maybe Max can help me here.
Honestly, we use it's just because we use it at scale and it's even not recognized like techniques. But honestly, if you're talking about techniques, it's vertical store decomposition. For example, classical example, if you work with payment systems, it's better to implement one integration and any additional integration should be additional stories. The same like I'm talking about some technical stuff because we have backend driven application, but we are mobile apps. We use technique which called like API first of all, and we treat about this API seriously. Our first task is define this API, and after that we could experiment together to push some code because we know that we agreed on this API. Of course, this API can be changed, but it's really important to spend time on it. And also about techniques, it's I could say it's feature toggling. For example, you could do some task, push on prod, and think about continuous integration because it helps to and also it's a good idea when we have something big. Of course, we have a lot of big stories. It's better to start with integration with a lot of steps, with dummy implementation, and you could do it together. Something like mob programming, when you sit together and work around this task to provide this big picture, and only after that you could split this functionality and work in parallel.
Okay, another question? Yeah. Yeah, so the question was whether we estimate the external dependencies and whether we rather take into the consideration the external dependencies into our cycle time. So this falls into the category of those tasks that are okay when they're longer tasks because they're like those by design. So if there's something on the third party that we can't control, well, definitely we can't do anything about this. And we take that into the consideration, yes. But, honestly, it's okay because this task, it takes just longer by design. We also have those kind of, one could say that the third party for a team could be another team, right? So it could be integration inside the company. and that's also, okay for those tasks to be longer.
And about integration, which type of integration you mean? For example, if you're talking about integration with payment systems, we could do just split all the stories vertically to achieve one functionality, also add another one. And if you're talking about integration between services in case of asynchronous communication, and in that case, it's important to think on API level to discuss this API together. When you work on such kind of migration, also important to check maybe some main cases to implement some basic functionality. Also, you could use pattern like it's called strangle when you started to another implementation, but at the same time support to implementation before you switch to another one. For example, in case of migration from Kinesis to Kafka, in this period we have two implementation of Kinesis and Kafka, and only after successful migration we switch off old. And of course, in some way, it adds additional complexity, but it's reduced risk because you have working system, and as Aleksej said, we data intensive application, and that is why it's not possible just to stop and wait. That is why, yeah, it's complexity which we have to pay.
Okay, more questions? Well, looks like we don't have any more questions. Let's go.
So we will be going through some online audience questions since we are probably done with the live audience. Thomas is asking, how do you make sure that people are not gaming the system? For example, just making the tasks smaller.
Yeah, so this is
could I ask this question?
No, I'd like to answer this first. Okay, so any kind of approach has its trade-offs, right? And we consciously try to educate the team rather than see them hack the process, right? So if your team is kind of trying to hack the system, then you have a bigger problem than tuning the cycle time. So Max, now you can jump in.
Yeah, I will try to answer in another way. Honestly, yeah, of course you could win any system if you want. In our case, we try to hire only major engineers who are interested in solving complex problems. And I will answer in short. We try to hire serious engineers who doesn't interested in this game. They want to solve these problems. They want to use good practices, and we have a big community. For example, I mentioned that our teams are cross-functional, and we have only one mobile engineer, iOS, Android in the teams. But between they work a lot together, and it's also like peer pressure. They make a review, they evaluate each other. That is why, in our case, it's not possible. Of course, maybe on another scale, if you have about thousands or developers, of course, it could be.
Okay, we have just a couple more questions. Actually, a follow-up question from Thomas came up. Do you also capture real lead time, including like the product metrics?
I believe we do. Yes, I believe we do. But that's rather a question to the product organization. But we could take this offline, and I could look it up. But I'm pretty sure we do.
I could add here, yeah, about this lead time. We did a lot of experiments, and for run this experiment, we have to to fill in some criteria. Is it successful or not? And of course, we have to track all this time from the beginning to the start. For example, our platform teams work a lot to give a lot of possibility to run this experiment quicker. Of course, we measure it, and we have experiment service, and this experiment service provides such kind of information. And we could use it in both ways. For example, we could analyze why we run a lot of experiments, but we don't make some decision after that, etc. But it's like Aleksej said, it's part of our product work, and it's not possible to answer this question in a simple sentence. It depends on type of experiments, and because we're talking about lead time.
Thank you. And the last question comes from Gitas. He's asking, what are the main techniques you apply to shorten cycle time?
I believe we already covered some of those. So task decomposition would be definitely one of them. Integration, like Max said, integration first, right? So if we need to integrate with something, we'd rather do like a dummy integration first and then do the rest to see that the integration is working. But yeah, what am I missing from the techniques?
No, you're right. I would like to add that the main technique it's our team composition, because we form our team around domains, and the main idea not to have a lot of dependencies between. Of course, in some way we could have these dependencies. It's natural, but if in our case it's a lot of dependencies, maybe it's better to rethink our team composition to combine some domain together, because of course if one team depends on other team, it doesn't help. That is why the main domain technique is right team composition, and we could use something like event storming when we try to find this bounded context, and we not try to build just feature teams, because in this case, of course, it will be really hard to achieve good result.
Yeah, so it's rather we try to build teams that can deliver cycle time, short cycle time by design, because they're end to end. Okay.
Thank you.
Thank you. Thank you very much. And feel free to come and talk to us. We're going to be here around. Feel free to come and see our booth. So we have some stuff there. So thank you very much again, and see you.
Thank you. Bye.